Okay, hi everybody. Tonight we are talking about exactly one topic, that's solving systems of linear equations by graphing. And we will figure out what that means as we go through this lesson. And we're going to start right with the do now. Okay, we can ignore what just showed up on the screen. And let's go on. So for our do now, I ask you to try these two questions. They are review. We have done them all before. And so this is what we are working on. Graph the line y equals 3x minus 2 and solve the system of linear equations y equals 2x and y equals 3x minus 3. Both of these things will be required as we go through this lesson, so please push pause now, do your best to answer these questions, and then come back and we'll go over them. All right, so for number one, we have this equation, graph the line y equals 3x minus 2. The easiest way to graph this is to remember this is in y equals mx plus b form, which means that 3 is your slope, and your y-intercept, b, is negative 2. So the way we graph this, once we have our y-intercept, is we look to see where this crosses the y-axis. Y-axis, it crosses it at negative 2. And we know that the slope is 3. Slope, remember, is equal to rise over run. So a slope of 3 means that that's your rise over your run, which means we need to think about 3 as a fraction. And what is 3 as a fraction? It's 3 over 1. So this means that your rise would be 3 here, and your run would be 1. So that means we go up 3. We start at our point, we go up 3, 1, 2, and 3, a rise of 3, and a run over 1. So we're going to put our next point right there. Okay, so we've gone up 3 over 1, and we get a point there. To find our next point, we go up 3, 1, 2, 3, over 1, we put our next point there. To do the next point, we go up 3, 2, 3, over 1, we put our next point there. And now we have enough points, we can just connect them with a straight line. And we have graphed y equals 3x minus 2. So it's just a matter of finding where you start from, your y-intercept, and then go using your slope to come up with the following points. Okay? Number two, we have done several times, solving this system of linear equations. If you know that they are both the same on the left-hand side, then you know they are both the same on the right-hand side. And so you get 2x equals 3x minus 3. And then when we solve this, subtract 2x from both sides, minus 2x. We have 0 is equal to x minus 3. Add 3, and we have that 3 is equal to x. But remember, what we're looking for when we're solving a system of linear equations is not just x, we're looking for x and y, the point where that is a solution to both of these. So we take our easier looking equation, y equals 2x, and we will plug in what we just found x to be, which is 3, to figure out what y is. Y is equal to 2 times 3, so y is equal to 6. And our solution, 3, 6, that is our solution to our system of linear equations. Now that was, what we just did is we solved this system of linear equations algebraically. That means we used algebra steps of doing the same thing to both sides of an equation to come up with answers that are numbers, and we didn't draw any pictures or anything like that. Now the point of today's lesson is we are going to figure out how to graph a system of linear equations and use the graph to give us our answer. But first, remember, when we're talking about a system of linear equations, what we're talking about is 2 or more sometimes, but at least 2 linear equations. Here's one. I'm sorry, I will actually color code this. So here is one equation here. And here's another equation here, this system of linear equations, we have two distinct equations. And what we are looking for is the point that is a solution to both of them. So if we plug in to each of, for x and y, we would get two true statements. Well, look what we've done here. We're going to talk about three different possibilities when we are graphing systems of linear equations. Here's the first situation. I take this blue equation here, and I graph it. That's this guy here. Y equals x plus 15. I take the other equation, the red one, and I graph it, and I get this guy here. Y equals negative 2x plus 20. Look what happens. I want to draw your attention specifically to this point right here. The point where both lines meet. That is going to be our solution. So if we can graph both of these equations and just look for this center point, then we found our solution. So the first possibility when we're graphing linear equations, systems of linear equations, is this one. We have intersecting lines, which means they have different slopes, and they intersect each other. So they have different slopes and different intercepts. So since we have this in y equals mx plus b form, you can just see your slopes are different, your y-intercepts are different, and so you know that you are going to have intersecting lines. Okay? So when we are talking about this kind of situation, which is what we're looking for, there is exactly one solution to it. And that is the point, once again, we'll highlight it, that's the point right here where the two lines actually meet. There are two other situations, however. Okay? So, one other thing that can happen, I can have one equation here and one equation here. I can graph them both. Y equals x plus 14. Y equals x plus 15. And look what happens. They are parallel, so they don't actually ever meet. When we have parallel lines, that means the slope is the same, and you can actually see that because the number in front of the x, it's really the same number both times. It's not written, which means it's a 1. We don't write the coefficient if it's just 1. And so I have the same slope both times, so I know that these will never intersect. And so what we write here is that there is no solution. When we have parallel lines, we will not have a solution. That is when we have parallel lines that have the same slope and different intercepts. Same slope but different intercepts. So you see my slope was the same. That's this guy right over here. That was the same, but my intercepts, 15 and 14, you see those are different. Because those are different, but the slopes are the same, you know you'll have parallel lines. The third possibility, however, is even stranger. If this is my first equation, and this is my second equation, well, let's graph the first one. I graph that here. Y equals x plus 15. And then when I go to graph the second one, it's right on top of the first one. And so that's obvious that that'll be the case because if you look at the two equations, they're exactly the same. What you have here is you actually have the same line. It has the same slope. So same slope, that's these guys here. They both have a 1 in front of them, so the slope is 1. And the same intercepts, 15 and 15. And when you have the same slope and the same intercepts, you have the same line. Those are going to be right on top of each other. So you don't have one solution. You certainly don't have any solution. You don't have no solutions. What you have instead is every point on the line is a solution to both. And so you have infinitely many solutions. That means you have an infinite number of solutions. What we're going to hope for most of the time is to have one solution. But you do come up with situations that have no solution or that have infinitely many solutions, and you have to know how to deal with those as well. Okay? So let's do some examples. We want to solve the following system of linear equations by graphing. And we have a system of linear equations that is given to us. This is a two-step process. Step one is actually quite simple. Solve both for y. Remember, when we need to graph both of these equations, which means we need to have them in slope-intercept form, it makes it very easy to graph. So I want to take my first equation, negative x is equal to negative 1 plus y, and I want y by itself. Okay? So what I'm going to do is I'm just going to add 1 to both sides and see what happens. I have those that are going to cancel out, so I have y equals, and then I have negative x plus 1. Because I want this in y equals mx plus b form, I'm just going to flip these around, but I'm not going to change anything. I'm just going to change which side everything is on. So y comes to the left-hand side, everything else goes to the right-hand side, and so I have y equals negative x plus 1. I'm halfway done with step 1. Step for the other one, I have x plus y equals 4. I want to solve this for y as well. This one's even easier. Take x away from both sides. I am left with y is equal to negative x plus 4, or x minus 4, but I want my x term to come first. Okay? So this is exactly what we have. We have y equals negative x plus 1 and y equals negative x plus 4. Well, what we are going to do now is we are going to graph these, but first we need to make sure that we know our slope and our y-intercepts. Here, our slope is equal to this number right in front of x. I only see a negative sign, which must mean that there is an unwritten 1 there. That's the only reason we wouldn't have a number, and so my slope is really negative 1. My y-intercept is fairly easy to find. My y-intercept is 4. I'm going to do the same thing to the other equation. Okay, so I look for my slope. It comes right here. Again, there's an unwritten number, so I know that must be a 1, so my slope is negative 1. And then my y-intercept is going to equal 1. Now I can just graph both of these. I will graph this one here in green, and I will graph this one here in red, just so that we can tell them apart. Let's do the green one first. I start with my y-intercept is 4, so I go up 4, and there's my first point. Now I know that my slope is negative 1. Well, negative 1, that's my rise over my run. So let me think about this as a fraction. It's negative 1 over 1. That means every time I run, I go right 1. My rise is going to be negative 1. Well, negative 1 just means down 1. So what I'm really doing is I'm going down 1 and over 1, and there's another point. Down 1 over 1, there's another point. Down 1 over 1, there's another point. Down 1 over 1, and you get the idea. And then I'm just going to connect these. This is my equation. X plus y equals 4, or with the way I rewrote it, y equals negative x plus 4. Now I'm going to graph the red one. I start with my y-intercept, which is now 1. So I go up 1, and I start there. And I have the same slope. My slope is negative 1, and that's my rise over run. So I know that for every 1 I go over, I'm going to go down 1, because my rise is negative 1. So I go down 1, over 1, down 1 over 1, down 1 over 1, down 1 over 1, and then I connect these. What do you know? I've got parallel lines. Anytime you have parallel lines, you know that they are not going to intersect. And if they don't ever intersect, then you know you will never have a solution to this system of equations. So what you can say here is that there is no solution because the lines don't intersect. Okay, that's all there is to it. We're going to try another example now. Okay, solving systems of linear equations by graphing. Once again, we have a new system of linear equations, and our step 1 remains the same. We need to solve both of these for y so that we can graph them. Okay, so I'm going to take the first equation, y equals 3x plus 2, and I'm going to solve it for y. All right, I'm done. Notice it's already in y equals mx plus b form, so I've already done, or I don't have anything to do for that one. So I can move on to the next one. 4x equals y. Well, the only thing I want to do here is get y on the left-hand side, so I need to flip these. Y equals 4x, and once again, I'm done because I have it in y equals form. Okay? And that's all. This one was very, very easy for step 1. We already have both of them as with y by itself. Now what I'm going to do is I'm going to go on to step 2. I need to graph both of these. So to graph these, I want to talk about my slope, m, which is the number right, the coefficient for x, the number right in front of x. And so I get m is equal to 3. My y-intercept is the other number, plus b, plus 2 here. So I know that my y-intercept is 2. I can easily graph this one now that I know what my slope and my y-intercept is, and I'm going to do that. I'm going to graph it in red right now. So I start with my y-intercept. I start at my origin and go up 2, and there's my y-intercept. And then I talk about my slope. Slope, m, equals 3. 3 is equal to my rise over my run. Well, rise over run, I want to talk about it as a fraction, so it's 3 over 1, because my slope was 3, and 3 over 1 is equal to 3. This means I'm going up 3 for every 1 I go over. So I go up 3, 1, 2, 3, and over 1. Up 3, over 1. And that's what I've got. That's my first equation. Y equals 3x plus 2. Now for my second one, I want to talk about what my slope and my y-intercept is before I start graphing. Again, my slope is the coefficient for x, so m equals 4. That's my rise over my run. So I think about 4 as 4 over 1, and that means I'm going up 4 for every 1 I go over. However, when I talk about my y-intercept, b, I look for plus b in this equation. Y equals mx plus b, and I look and I don't see a plus b, which must mean that my plus b is really plus 0. And so b is 0. That's the only reason we would not write it, otherwise there'd be a number there. So if b is 0, now I'm going to go ahead and graph this. I start with my y-intercept, which is 0. That means I'm at the origin. And then I'm going to find my slope. I go up 4 this time. 1, 2, 3, 4. Up 4 over 1. And then I do it again. Up 4, 1, 2, 3, 4 over 1. I think I found where I'm going to intersect, because they both have this same point in common. Let me highlight it right here. Right there is where both points actually meet. So I can say that that point right there, the intersection, is my solution to my system of equations. Okay? So all I got to do is figure out what that point actually is. Well, I went over 2 and up 8, so this is the point 2, comma 8, and so that is my solution to my system of equations. So all we had to do, once we graphed this, oh, I am using disappearing ink, that's probably not what we want to do. 2 comma 8. Once I graph these two lines, all I have to do is look for the intersection, and that is my solution. So this is another way to solve systems of equations, is just graph them and see where they intersect. Let's do one more. We have the equation negative x plus y equals 8, and y minus 8 equals x. So what I want to do, once again, step 1 remains the same. Solve both for y. So I will start with my two equations. Negative x plus y equals 8, and y minus 8 equals x. I want to solve for y, and so what I'm going to do, let's start with the one on the left. Try to get everything away from the y. So to undo the minus x, I add x to both sides. Plus x. Negative x plus x add up to 0, so I can just cross them out. And I get y equals 8 plus x, or I know that I want it this way. I want the x term first, so x plus 8. And I have y by itself. Now I'm going to do the other one. I want y by itself. I need to get rid of this negative 8, so I add 8. I add 8. And I wind up with y equals x plus 8. Well, you could probably see right here that something funny is going to happen, because I have the same equation twice. Y equals x plus 8, y equals x plus 8. So I can go ahead and graph this, I really can. My slope is going to be the number in front of x. It's not written, that means it must be a 1, so my slope is 1. And my y-intercept is going to be my 8. Okay? So let's go ahead and graph it. Because they're both the same, I'll just graph them. I'll graph it in black, not do green or blue. So I start with my y-intercept. I go up to 8. That's my y-intercept there. And then I start finding other points with my slope. My slope is 1, which means my rise over my run, must equal 1. And the only way for that to happen is if it's 1 over 1, which means my rise and my run, as I go up 1, I go over 1. So up 1 over 1, up 1 over 1. I've got this line right here. And this is actually both my green and my blue line. So I can draw it on top if I want to. My green line and my blue line happen to be the same thing. So what do I say here? I say that there are, I say this, both equations are equivalent. So there are infinitely many solutions. And again, what that means is that I have anything that is a solution for one equation will of course be a solution for the other because they're the same equation. Okay, so I can't talk about a single solution, but any solution that's a solution to one is a solution to the other. Okay, this one is for you to try on your own. 2x plus y equals 1. Negative 3x plus y equals negative 9. And I have provided you with the answer so that you can try this on your own, just like we have been doing, and make sure that you have gotten the right answer. And that is going to be 2, negative 3, but you need to do the work to see how you would get that. Okay? And then finally, we're going to do one final question. We're going to graph a system of linear equations to solve a problem that is provided to us. Okay? So right now we have this problem. A bus leaves the school traveling west at 50 miles an hour. After it travels 15 miles, a car follows the bus traveling at 55 miles an hour. After how many hours will the car catch up with the bus? Here we have a classic problem where one vehicle leaves first but goes slower, and a second vehicle leaves after, but it's going quicker. So you can think and kind of think to yourself, eventually they're going to be in the same place at the same time. It's kind of like one car is chasing the other. Well, using a system of equations, we can figure out exactly how long it will take for that to happen. Okay? So what we're going to do is we are going to first set up our equation, which means we need some variables. We've got this variable. We're going to talk about t as time in hours. And we're going to talk about d, our other variable, as distance, and that's going to be in miles, because we are talking in miles per hour. Both speeds are given to us in miles per hour. So that's what we want to talk about. And then we want to think about how we can talk about the equation here. How do we turn these into two equations? Well, the car is easy. Figuring out how far the car has gone is really quite easy. The distance for the car, how do I find that? Well, the car is just traveling at 55 miles an hour. So d, the distance, is going to equal 55 times how many hours I've been going, so times h. So d is equal to 55 times h. Or I'm sorry, not times h, times t, because t was the variable we picked for time, not h for hours. So the distance is equal to 55 times t. The bus is a little bit trickier, though. We know that it's going 50 miles an hour, 50 times t, but we also know that it has a head start. When we're talking about the distance there, it has a head start because it has gone, let's look back at our problem, it has gone 15 miles before the car ever starts. So we say that the distance for the bus is equal to 50 times t plus the 15 miles that it had gone in the beginning before the other one started. And once I have both of these equations, I just need to solve for d, which is already done for us. And so I can go ahead and graph these. For my first one, for my second one, d equals 55t. I want to talk about two things. I want the slope, m, and I want my y-intercept, b. Well, m is the number in front of t, so I get 55. B is my y-intercept, but there's nothing here, so it's really plus 0, which means that my y-intercept is 0. I can now go ahead and graph this. I start with 0. My y-intercept is 0, so I start here. And I go up 55 for every one that I go over. So up 55 over 1, that's going to be right about there. Up another 55 over 1, that's going to be right about there. Up another 55 over 1, that's going to be right about there. For my bus distance, I have that my slope is equal to the number right in front of t, so that's my slope is 50, and my y-intercept, b, is going to be this other number, 15. So I will start at 15, which is right about here, and for every unit that I go over, I will go up 50. So I go up 50, I go up 50 over 1. Up 50 over 1. Up 50 over 1. And what I'm going to do is, because I cannot write these as precisely, I'm going to reveal what's already there. Okay? I'm going to erase my lines, or my dots. And this is what happens if we graph these. And then we just look for the point where they meet. It's a little bit tough to see on this graph because it doesn't meet at an intersection. But we've got this point right here is where they meet. And what spot is that? Well, that's about 3 hours. How far has it, in fact, it's exactly 3 hours. And how far have both of these gone in 3 hours? Well, you can either use your equation to find out. D equals 55t, or D equals 50t plus 15. Either way, t is going to be 3. And you'll get what d is. Or you just kind of look here. Where is this? It looks like it's about a third of the way up between 150 and 175. And in fact, turns out that d is 165. Okay? So my solution here was, after how many hours will it catch up? Well, after 3 hours, 3 comma 165. And what does that 3 comma 165 mean? It means that these two vehicles are in the same place after 3 hours. And how far have they gone? 165 miles before they have, the second has caught up with the first. Okay? So we have lots of problems like this that we can do once we know how to graph linear equations and solve a system of linear equations by doing so. That is all for this lesson. Thank you for being a good audience.